Nice to meet you all. My name is Mai. I'm the co-founder and CTO at HUD, and along with this awesome group of people, we're building a sensor that runs in production and gathers context so that humans and agents can solve their production incidents faster. And today I'm going to go over how Python monitoring evolved throughout the years. It's mostly going to be about what Python core can do for you and how to be able to choose the right way to monitor according to your needs, hopefully with some practical, actual examples that you can take to your day-to-day. So what really is monitoring is not that trivial. What is it that I want my monitoring to look at? I want to understand what's going on in production. There are so many tools and so many configurations I can take care of, and yet somehow production still catches fire every once in a while, and we also always have either one of two problems or both of them. One is, oh, we have so much data, it's so hard to find the right signal and I'm getting all this noise. And then the second problem is, I don't have that specific log that I need, let's add more logs and wait for it to be reproduced. Theoretically speaking, of course, I'm sure that every single one of you is experiencing something completely different. But it wasn't always like that. So let's take a deep breath and go back in time and see how it actually evolved to being like that. We're starting in 1996, Python 1.4 or earlier. That was actually before the PEPs started, so I can't guarantee exactly when it was. And just to get a hint of how much time has passed since then, the Billboard's top song in 1996 was Macarena. It's a long time ago, okay? And that's where we were introduced with set trace and set profile, which I don't know if you're all familiar with, but I'm sure you're all using in your day-to-day lives. This is basically an infrastructure that lets you trace every single line of your Python code. And when you're setting a debug trace on your PDB or on your PyCharm, that's what's actually happening behind the scenes. And we also have set profile. Set profile lets you trace a function level, and that also includes calls to non-Python code. So if you're calling another process or C code or something like that, it also allows us to do this. And then the bad part about that is that both of those have a very severe performance overhead on the system. They were designed to let us debug things locally on our computer in eras when we would write code and put them on some floppy disk or CD-ROM and send them to some server. This is not how we are working today, but again, they are not meant to be used for production debugging, and therefore they introduced quite a significant overhead. And yet, if I want to debug something, it's still helpful. If we'll go into the Python source code, we can see that we have this trace dispatcher. Basically, how it works when you add a PDB debugger is that the first thing that happens is to even understand if you really need to trace or not, and then go over this huge if-else place where we take the different events that are happening, the lines, the C calls, the returns, the exceptions, and we dispatch them to the relevant place we want to handle. And that's basically how it's used when you set that debug exception. And once that happens, the dispatcher allows us to run whatever it is that we want, get the variable values or anything like that. So we have set trace and set profile. They can see everything. That is a good thing because we never miss any event. But it can also be a bad thing because we get a lot of noise. We have to actually dispatch and handle every single thing that happens on the system. They are safe, and when I say safe, what I mean is that it's not going to harm your application. Everything that happens in those tracing is going over the application, so we don't have any risks in that term, but there is a very major overhead. And maybe I don't care because I'm debugging locally, but for sure I won't be able to do that when I'm building a system that is customer-facing. We move on to 2003, Python 2.3. Any guesses on the billboard? We have Justin Timberlake, Rock Your Body. That was cool back then. And what else was cool? Import hooks were very cool. We have PEP 302, that's in 2002. And that's where it started. There's actually an incremental process throughout 10 years until we get to the point where this is today, where import hooks basically allow us to interfere with the model loading process. So unlike the lines or the functions that we've seen before, import hooks let us basically put a hook on the import quite literally. And then once a model is being imported, I can stop, go over it, decide about the specific hooks and manipulations that I want to set in place. For example, I can wrap specific code that I want to be monitored. I can track the loaded models. For example, for security reasons, maybe I want to know the exact Python modules that are being loaded into my system. And it is very commonly used by application performance monitoring systems, or APMs, like Datadog, Grafana, Dynatrace, and so on and so forth. So this is how it basically looks like, and this is not Python code. This is Python code. This is not the source code of Python, just to sort of give you a hint of how it looks like. So usually when a module is loaded in Python, we start by taking the code, we load it to memory, we compile it into what is called an AST, an abstract syntax tree, and then to bytecode. What we can do here, and this is again the magnificent power of Python, we can compile our code and leave it in the AST state. So basically turn our code into an abstract syntax tree and then run a transformer that will allow us to change a bunch of stuff. Let's say we wanted to implement setTrace using import hooks. How would that look like? Basically, we can build a transformer like that goes over every single function that is a function definition, and then decide to log function invocations. So kind of like a decorator, but that is automatically added to all functions. For example, we could use this to detect dead code and functions that are not invoked at all and could be deleted, or decorate our functions with specific instrumentations that we would be interested in. And once this happens, we call compile again, we take the code after the transformation and turn it into bytecode, and everything continues exactly as it was. The most common usage is really the APMs, the traces that you are familiar with. What actually happens in the background is a huge operation built by the APM providers and OpenTelemetry to set the specific modules that we want to trace, like database calls or HTTP requests or gRPC or anything like that. And they basically instrument the specific functions that are doing these operations, and that's how we basically see what's going on. There is still a major problem here, or challenge, because they don't instrument our code. They only instrument the third-party modules that we're looking into, and then when we try to understand what's going on in our systems, we still need to add logs and spans and traces or custom metrics. And that requires a lot of manual work that we really want to do, but our product team really wanted that feature out last week, and it just kind of happens that these things are not always prioritized. It is dangerous, and in dangerous, what I mean is that we are manipulating the code, and bugs or wrong interfaces there could actually harm the way that the operation and the application works. I'm not saying we shouldn't do it, I'm just saying we need to be very well aware of that fact. But it is very performant in the fact that we are actually just changing the code base, and it would look just like I actually added that code, or at least it can be performant. Of course, everything could be either performant or not, depending on the instrumentation, but the infrastructure does allow that, which is pretty awesome. 2006, Python 3.6, a very exciting version in general, a lot of new cool features. Justin still controls our lives, but a different one. This time it's Justin Bieber, which starts to feel a little more modern, right? And I do think, like, at least from our customers, we're still seeing some Python 3.6 in the wild. And that's when eval hooks joined the game. It's a PEP 523, actually authored by Brett Cannon, who's also speaking in this EuroPython, which is cool and exciting. And what this basically allows us is to add frame evaluation to CPython. So this is the first time that we can interfere on the frame level. If we had functions and lines, and then we had modules, now we have the frames, which are more relevant and more fine-grained to what we want. And we can also completely replace the code execution logic. If we wanted to open a terminal and type in hi, we would still be able to do that because we're using CPython and we have all that power. And let's look at the implementation. I'm sorry, this is EuroPython, but I'm going to show it in C because Python is beautiful C anyway. And basically how it looks like is that the first thing that we have to do is to filter. Once an frame is being evaluated, we have to understand if we want to monitor that or not in terms of the context. And then once this happens, we can maintain the state of the exceptions and so on and so forth, because this is actually a proxy of the frame before it's being evaluated and executed. And obviously that is also why we have to keep using C for that, because writing Python code that will be evaluated on every frame loading, well, those frames also contain the code that you're writing is going to basically make the world explode, or at least your application. So C it is. So the problem with evil hooks is that with great power comes great responsibility, as we've learned in various cultural remarks. We can see everything, which, as we described before, could be a good thing, could be a bad thing, but it is very, very powerful. They are rather dangerous. Again, we're writing C code. We can do whatever we want. We can crash the application. Of course, we wouldn't want that, but it just might happen because we have great power. And they can be very, very performant because we're talking about pure CPython operations that allow us to look into everything, machine state, threads, and so on and so forth. So what do we have so far? We have set trace and set profile. We use them every single day. They've existed since forever, but they are not performant. And that is something that is built into the way that they operate. And sometimes we want to know what's actually going on in production, because that bug that I've been chasing for 2 weeks is not being reproduced on my computer. It really, really did work on my machine, right? We have import hooks and evil hooks that allow us to see what we want to, but they are dangerous and mostly they are labor intensive. We have to know what it is that we want to get from them for them to work. And I kind of want the combination of the two, but at least back then it didn't exist. So what can we do? We can add manual instrumentations with the evil hooks. We can occasionally try to reproduce locally, but it's not quite there yet. But luckily, we are living in the present and not in the past. So let's get back from a time travel to relatively lately, 2023, Python 3.12. Who's using 3.12 or more in production? Wow, I'm impressed. Nice. Obviously, it's not even the latest anymore, but it is quite modern. I think you could be very proud of yourselves. And Miley Cyrus will also be very proud of you. And that's starting to feel like today-ish. And that's where we were introduced with sys.monitoring. This was a PEP that is specifically aimed at low-impact monitoring for CPython. And I think that's like one of the things that are so amazing about Python is that the community is pushing this infrastructure forward, and every time new things come over, and this is like an amazing feature that is really meant for us to be able to monitor with low impact so that we can run in production, so that we can understand what's going on without creating these weird sandboxes, which is pretty awesome. I'm quoting from the document here saying that code run under a debugger on 3.12 should outperform code run without a debugger on 3.11. Profiling will still slow down execution, but by much less than 3.11. And when you think about it, this is huge. The ability to debug in a way that's still more performant than what we had in the previous version. How does that work? Well, let me tell you how it works. Sys.monitoring gets the best of both worlds. It's simple, like set trace, and it lets you define what you want to see. It's also performant, like Evo hooks, because it's running on native infrastructure. It's basically an API for monitoring, where the user can select the specific events that they want to monitor and allow dynamic filtering on top of that. I believe it's the future of modern debuggers, and obviously it's going to take some time until the world adjusts to that, but I do think we're getting there. And it's so simple. The complex logic is actually on the setup time on setting those places. We can see that we start with setting up the monitoring. We define the specific events that we care about, the returns, the starts, the lines, the raises. If I don't set these events, they're not going to be tracked, and they're not going to be signal and noise in my way. And once this happens, I can register the callbacks and react to them, which is very simple and easy to use. And that's basically it. We have sys monitoring in place. Once this happened, the dispatch could be minimal, or it could do whatever it is that you want to. And we have the ability to see everything. We can see everything, but we don't have to. It's way less intrusive, and it can be performant, which is what you would want from a monitoring system to do. So let's try to summarize what we've seen so far into a practical framework for you to be able to understand what you want to do. First of all, if you don't care about performance, use set trace and set profile. Keep debugging the way that you do. It works, it's great, why not? If we care about performance, we have the import hooks, which can really help us if we know exactly what it is that we want to track. We have the Evo hooks that are more complete in what they can do for us, but they require us to get back to writing C code. And sys monitoring kind of gives us the best of both worlds if we're talking about modern infrastructure. About what comes next, I would say ask me again in 2 years, but I'm sure that things are happening, and there's definitely more room to grow there. In summary, we don't always know where to monitor, and that's one of the challenges here. Modern Python introduced a lot of innovation, and if you're using modern versions, I really urge you to look at that, have a look, and think about how it can help you understand what's going on. And production data sheds light on what our users are experiencing, which is really important, and that is why we want to be able to monitor with very, very minimal overhead and very minimal labor in terms of engineering overhead. But it's been like 15 minutes, and I haven't said AI yet. So let's talk a bit about that. This is not an AI talk, but I do think it's relevant to talk about the fact that these systems were built by humans for humans, and our new friends are starting to join the gang. They're building features with us, but they have no idea how that code that they're writing behaves in production. And I think monitoring is going to change because of that as well. As you know, all production incidents always happen when you're either asleep or during your weekend, or both. But Copilot never sleeps, which is pretty useful if you think about that. And I wanted to share an example. I think there are a lot of companies and organizations that are trying to build tools around that. And some of them are talking about better anomaly detection. Some of them are talking about trying to automatically triage. And I wanted to share one example of something that we're doing at HUD as an example to kind of open our minds to how would monitoring look like on that edge. I think there are a few components there. First, there's the baseline collection. If I don't know how the system behaves, it's very hard for me to understand if that thing that I'm experiencing is normal or not. Maybe it always has a 10% failure rate. Maybe things are taking 1 or 5 or 10 or 20 seconds. So I need to understand what the baseline is and what I care about. Then we have the layer of dynamic collection on demand. So once I see something is going on, I want to gather all the context so that humans or agents would be able to fix it. Then we have the agentic triage. Today, a human being would go over the data and opinionate about whether we need to call someone or whether we need to stop everything and start handling this issue. And of course, the resolution itself is something that today, even if we're using Cursor or Copilot or Augment or Claude or whatever it is, I would still have to look into that production incident and try to understand what's going on. Why? For example, one of the things that we are doing today is that once the sensor detects that something's going on, we automatically capture that context. That would be the machine state, the parameters, the stack traces, and all of those. And then we can create that issue. And first of all, it's created automatically. And again, there are multiple tools that can do that. The second part is the business impact, because we don't just want to understand what went wrong, we also want to understand if we should care about it. And the likely sources and the context code. And now we can say something like, Claude, fix it for me. And in these cases, and again, I'm showing Claude, but Copilot also has these capabilities, we would be able to open a branch, explain what we already did to fix it, and get to the root cause, and open a PR if needed. So again, I'm not talking about some self-healing, crazy machines writing code for production. But instead of us going over that and trying to opinionate whether we should fix it or not, we can get to a point where those agents help us understand what happened and why it happened. And now we can start iterating over the solution. And these things are happening today. We can also, of course, comment on some follow-ups, and that would still work. But the main thing I would want you to take from this session is what you see is what you can fix. And those agents, they can see everything that's going on in your code base and in your Git history or whatever system that you're using. But the context that they're blind to in production will not be able to help them reason over to build code that actually works in production and to fix issues faster. And we have all these amazing infrastructure that Python allows us in order to monitor and to get that data. We just need to make sure it's also streamlined. And the way we think about it is, what is the things that matter? What are the things that we need to know as humans or agents, it doesn't matter, in order to be able to understand if that issue matters or not, and all the context needed in order to fix it. And in Python, it really is possible to get to the point where we have that coverage, which is super awesome. Thank you so much. If you have any questions, I'm still around. Any questions, thoughts, music recommendations?
So regarding music recommendations, there is a very nice Polish band called Lordofon, Lordofon. I recommend it. Thank you.
Thank you. Woo! That's nice.
So I'm going to be a bit more off topic. I was going to ask if any of the APMs already use this sys.monitoring, any like mainstream software already using sys.monitoring?
Yeah, so the question was around usage of sys.monitoring in APMs. I think the classic APMs have some struggles with using these things because they have to assume that some of their customers are using older versions of Python. I can share that for us, we do have some forks. So for newer versions we're using that. We are seeing OTel also looking into these things. For Datadog, the last time I checked, not yet, but again, I assume that they are very smart people and that they have the tech savviness, and it's a matter of market share. And if we all upgrade our versions, they'll get to that faster, and we will be able to see better performance over time.
Any more questions?
All right, I'll still be around if you want to catch me on one-on-one, either here or LinkedIn or whatever. Always happy to geek out on monitoring.
Thank you very much. I think we will try suggestions with sys.monitoring and with Copilot. And please, a round of applause